Find the slope of the curve y equals x squared minus 2x minus 5 at the point 2 minus 5 by finding the limiting value of the slopes of the secant lines. The point 2, negative 5 is here. And if I were to choose a point, say here, that's on the graph, and then draw a line through those 2 points, that would be a secant line. I could draw another secant line if I were to locate a point that on the graph is closer to the point 2, negative 5, and then draw a secant line here. I could continue to do this by choosing points that are closer and closer to the point 2, negative 5, and drawing secant lines. And when we do this, we are diminishing the difference between the x-coordinates of these points. If I were to do this until that difference between the x-coordinates was 0, then what I would eventually have is a line that just passes through the dot 2, negative 5, and would actually be the slope of the curve at that point. That line that I just drew would be a tangent line, not a secant line, since it would only hit the graph at one point. The difference that we talked about between the x-coordinate for the point 2, negative 5 and the x-coordinate for all these other points we will refer to as h. The slopes of these secant lines we could find using the slope formula. Change in y over change in x. The slope formula, recall, is y2 minus y1 over x2 minus x1. If I think of our point 2, negative 5 as x1, y1, and then the difference between the x-coordinates of any arbitrary point and our point 2, negative 5 to be h, then the x-coordinate would be x plus h, and the y-coordinate would be f of x plus h. And then we could call that point x2, y2, and then substitute all of this into the slope formula. So we would have f of x plus h minus f of x divided by x plus h minus x. And then we can see that the x's would cancel in the denominator. So we would have f of x plus h minus f of x over h. Now this would be the slopes of the secant lines. But what we want is the slope of the tangent line. So the slope of the tangent line, or in other words, the slope of the curve at that point, would be found by letting the limit of h go to 0 for this quotient, f of x minus h minus f of x over h. Now we need to do this for this specific curve, y equals x squared minus 2x minus 5. So we could start then by finding f of x plus h. Well, that would be x plus h squared minus 2 times x plus h minus 5. Multiplying all this out, we would have x squared plus 2xh plus h squared minus 2x minus 2h minus 5. Then, if we were to subtract f of x from that, as we see in the numerator of this quotient, we would have x squared plus 2xh plus h squared minus 2x minus 2h minus 5 minus, now I'm going to subtract 3 terms here. So I need to make sure that I put it in parentheses. X squared minus 2x minus 5. And it's necessary that I put that in parentheses because this negative out front is going to distribute. So we have x squared plus 2xh plus h squared minus 2x minus 2h minus 5 minus x squared plus 2x plus 5. And now some things are going to cancel, such as the x squared terms, the 2x terms, and the constant terms. So this leaves us with 2xh plus h squared minus 2h. So now we can divide this 2xh plus h squared minus 2h by h. And we would have f of x plus h minus f of x divided by h would be 2xh plus h squared minus 2h divided by h. And we see that we could factor an h from the numerator. So we would have h times 2x plus h minus 2 divided by h. And these h's will cancel. So f of x plus h minus f of x divided by h would just be 2x plus h minus 2. Now, why did we do all of this work? Well, when we look at this limit, we have the limit as h goes to 0, but h is in the denominator, and we can't substitute 0 in a denominator and wind up with a real number. So what we have to do then is manipulate this until we get to a point where we can substitute 0 for h. So the limit as h goes to 0 of f of x plus h minus f of x over h would just be then the limit as h goes to 0 of 2x plus h minus 2, which would just be 2x minus 2. Now, at the point 2, negative 5, x is equal to 2. So the slope then of this curve at the point x equals 2 would be 2 times 2, substituting 2 in for x here, minus 2, which would be 4 minus 2, or 2. Looking at our graph, that looks like a reasonable slope, positive 2.